Imagine waking up one morning to find your phone without signal, the internet completely gone, airplanes grounded, the stock markets frozen, hospitals in chaos, satellites no longer responding, and the world suddenly slipping back into the dark ages of the 1800s, all within a matter of minutes. No global war, no nuclear explosion, just the silent yet devastating hand of our very own star. This isn't a scene from a science fiction movie. It is a real and terrifying possibility. The sun, the glowing ball of nuclear fire that sustains life on Earth, also carries within it the power to disrupt our modern civilization in ways we can barely imagine. Scientists call it a solar storm. And today, we will peel back the layers of this cosmic threat, uncovering how close we have come in history, how vulnerable we remain, and what the next solar catastrophe could mean for humanity. This is Starsky Science, and if you are fascinated by the mysteries of the universe, make sure to subscribe and stay with us, because what you're about to hear could very well be one of the most important space threats facing our generation. For over 4.5 billion years, the sun has been the ultimate life giver, providing heat, energy, and stability to Earth. Every plant that grows, every raindrop that falls, every heartbeat of every living creature, in some way, is tied back to the power of our star. Yet, the sun is not a peaceful, calm ball of fire. It is a violent, raging sphere of plasma, constantly boiling, twisting magnetic fields, and releasing bursts of radiation into space. Most of the time, Earth is shielded by its magnetic field, our invisible protective bubble. Without this, our planet would have been stripped of its atmosphere long ago. But when the sun unleashes something truly massive, even Earth's magnetic shield struggles to hold the line. These violent events are known as solar flares and coronal mass ejections, and together, they can generate geomagnetic storms capable of frying power grids, disabling satellites, and pushing humanity into a global blackout. NASA scientists describe the sun as a variable star, meaning it has cycles of calm and fury. Every 11 years, it moves through peaks of solar activity, known as the solar maximum. During these periods, giant sunspots dot the surface, and solar flares erupt like cosmic volcanoes. It is in these moments that Earth becomes most vulnerable to a direct strike. To understand the magnitude of this danger, we need to look back to September 1, 1859. British astronomer Richard Carrington, while observing the sun through a telescope, noticed an intense flash of white light, the first recorded observation of a solar flare. Just hours later, Earth was hit by the most powerful geomagnetic storm in recorded history. Telegraph wires across Europe and North America sparked uncontrollably. Operators were shocked by electric currents, and in some cases, entire telegraph systems burst into flames. The northern lights, usually confined to the polar skies, were seen as far south as Cuba, Jamaica, and Hawaii. Newspapers reported that miners in the Rocky Mountains thought it was dawn in the middle of the night because the auroras were so bright. The Carrington Event, as it came to be known, was a stark reminder that the sun is not just a distant background actor in the play of life. It is an unpredictable and dangerous force that can change our world in an instant. Now, pause for a moment and imagine if an event of that scale were to happen today. Unlike 1859, our world is entirely dependent on electricity, communications satellites, GPS navigation, the internet, and a global network of connected systems. A storm of that magnitude would not just cause inconvenience, it would be catastrophic. NASA and the European Space Agency have warned repeatedly, humanity's technological infrastructure is fragile against solar superstorms. Our power grids are built on long wires that act like giant antennas. When a geomagnetic storm hits, it induces currents that can overload transformers, causing them to burn out. Unlike telegraph lines in the 1800s, today's high-voltage transformers are massive, expensive, and difficult to replace. If a storm of Carrington's strength struck now, some regions could lose power for weeks, months, or even years. In 1989, a much smaller storm than Carrington struck Canada's Hydro-Quebec power grid. Within 90 seconds, the entire province was plunged into darkness. 6 million people lost power for 9 hours. In the middle of winter, airlines lost communication with ground control, satellites malfunctioned, and radio signals went silent. And that was just a taste. NASA researchers have also calculated the odds. According to a study in 2012, there is about a 12% chance per decade that Earth could be struck by a solar storm as powerful as the Carrington Event. That might sound small, but think about it, a 1 in 8 chance every 10 years. Over a human lifetime, that's almost a certainty. When a coronal mass ejection, CME, is launched from the sun, it carries billions of tons of plasma, threaded with magnetic fields, hurtling into space at millions of kilometers per hour. If Earth happens to be in its path, those fields slam into our magnetic shield. Depending on their orientation, they can either bounce off harmlessly or latch onto Earth's magnetic field and rip it open. When that happens, energy floods into the upper atmosphere, creating auroras and driving electric currents into the ground. Satellites can be blinded, spacecraft electronics fried, GPS signals scrambled, and radio communication disrupted. On the ground, power grids absorb surges of electricity, and pipelines corrode faster due to the induced currents. In a worst-case scenario, multiple continents could lose power simultaneously. With no electricity, water systems fail because pumps stop working. Hospitals run out of backup fuel. Transportation collapses. Banks and digital transactions freeze. Modern society, as we know it, rests on a delicate foundation of electricity and data, and both are vulnerable to the sun's wrath. Physicist Dr. Daniel Baker of the University of Colorado has often warned, a solar superstorm could be the costliest natural disaster of our time. His team estimates that the damage to global infrastructure could exceed $2 trillion in the first year alone, and recovery could take a decade. NASA's Solar Dynamics Observatory continues to monitor the sun 24/7, scanning for eruptions and flares. But here's the unsettling truth. Even with all our technology, the warning time we get is shockingly short. From the moment a CME is detected, it may take anywhere between 15 hours and 3 days to reach Earth. That's not much time to prepare for global chaos. The US government, along with other countries, has classified solar storms as a low-probability, high-impact disaster in the same league as asteroid strikes or supervolcanic eruptions. Yet, unlike an asteroid, solar storms are guaranteed to happen again. The only uncertainty is when. Before we dive deeper into the science of these cosmic tempests, let me remind you once again, if you're fascinated by the idea of space, the unseen threats around us, and the science behind them, make sure to subscribe to Starsky Science. Your support helps us keep exploring these stories and bringing the wonders and dangers of the cosmos to you. It may comfort you to think that such an event is rare, and we've been safe since 1859, but the truth is, we've already had some very close calls. In July 2012, the sun unleashed a massive CME, comparable in strength to the Carrington Event. Fortunately, Earth was not in its path. Instead, the storm blasted through the orbit where our planet had been just 9 days earlier. In the words of NASA scientist Daniel Baker, we dodged a bullet. Had Earth been aligned differently, the 2012 event would have caused worldwide chaos. This near miss revealed just how fragile our situation really is. We don't have centuries between these storms. They can happen within our lifetimes. And the only factor that saved us in 2012 was sheer luck. As we continue this documentary, we will explore how solar activity is monitored, how satellites give us precious warning, and what the global consequences of a direct strike could really look like. But perhaps most importantly, what can we do to prepare? Can humanity shield itself from the sun's anger? Or are we destined to experience another Carrington-level disaster? The sun is not just a shining beacon in our sky, it is a ticking time bomb. And in the next part of this series, we will uncover the cutting-edge science that seeks to predict the unpredictable, before we reveal the terrifying reality of solar storms through history. Then now we must go deeper into the very heart of the sun itself. Because to understand how these cosmic tempests can shake our world, we need to understand the engine that drives them. And that engine? sitting 150 million kilometers away, is not the peaceful golden disk you see rising every morning. It is a roaring furnace of nuclear fire, more violent and unpredictable than most of us ever imagine. At its core, the sun fuses hydrogen into helium at temperatures exceeding 15 million degrees Celsius. Every second, it releases more energy than humanity has consumed in its entire history. But this energy doesn't simply radiate outward in a smooth flow. It bubbles, twists, and churns as plasma electrically charged gas rises and falls like boiling water. Because plasma conducts electricity, it generates powerful magnetic fields. These fields do not sit still. They twist, snap, and realign. Think of it as the sun's version of earthquakes, only instead of land. It's magnetic energy building up and exploding outward. These explosions are what we call solar flares and coronal mass ejections, CMEs. A solar flare is a sudden flash of radiation across the electromagnetic spectrum. X-rays and ultraviolet light surge outward, reaching Earth in just 8 minutes. These can disrupt radio communication almost instantly, especially across the sunlit side of the planet. But flares are just the beginning. The real danger lies in coronal mass ejections. A CME is like a tsunami of solar material. Billions of tons of charged particles hurled into space at speeds up to 30 kilometers per second. If aimed at Earth, it becomes a storm front, crashing into our magnetic shield and setting off a geomagnetic storm. Dr. Madhulika Guhathakurta, a NASA heliophysicist, once described it this way: a CME is like taking a piece of the sun and throwing it at the Earth. The sun doesn't rage equally at all times. Every 11 years, it swings between quiet and violent phases. During the quiet phase, called solar minimum, sunspots are rare and eruptions are less frequent. But as it climbs toward solar maximum, the surface becomes peppered with dark, magnetically active regions, and storms grow more frequent and intense. We are right now heading into another solar maximum in the 2020s, and this raises an important question. Are we prepared if the next Carrington-level storm erupts during this peak? Today, humanity does not watch the sun with ground telescopes alone. We have built an entire fleet of solar observatories stationed in space, each with a critical role. SOHO, Solar and Heliospheric Observatory, has been staring at the sun since 1995, giving us an uninterrupted view of CMEs. SDO, Solar Dynamics Observatory, launched in 2010, watches the sun in multiple wavelengths, capturing eruptions in stunning detail. Parker Solar Probe, humanity's daring mission, is flying closer to the sun than any spacecraft before, sampling the solar wind directly. Stereo spacecraft give us a 3D view of eruptions, tracking their direction and speed. Despite all this, our warning system is limited. When a CME heads toward Earth, we can see it leaving the sun. But the crucial detail, whether its magnetic field will align in a way that can penetrate Earth's defenses, is unknown until the storm is almost upon us. We only know for sure when the cloud of particles reaches the ACE or DS Cover satellites stationed at Lagrange Point 1, just 1.5 million kilometers from Earth. That gives us, at best, 15 to 60 minutes of real warning before the full impact. Let's imagine it. A Carrington-class CME leaves the sun, directed perfectly toward Earth. Within 8 minutes, solar flares already begin disrupting radio signals. Airplanes over the Atlantic suddenly lose high-frequency communication with controllers. Military radar screens flicker. Hours later, the particle storm slams into satellites. GPS systems start to drift. Navigation signals scatter. And some satellites reset or go dark entirely. Television signals vanish. Internet backbones, depending on satellite timing, begin to falter. Then the CME cloud arrives. Earth's magnetic field rattles like a bell struck with a hammer. Auroras explode across the skies, seen as far south as Mexico and India. People cheer at the sight, but beneath the glow, chaos unfolds. Power transformers in North America and Europe absorb surges of electricity. Some overheat and catch fire. Others shut down permanently. The grid begins to collapse. First, localized blackouts, then cascading failures. Water pumping stations lose power. Mobile phone networks crumble. Airports shut down. Banks cannot process digital payments. Within hours, modern life is suspended in the affected regions. Professor Peter Riley, a solar physicist at Predictive Science Inc., once made a chilling statement. It's not a matter of if, but when. We are overdue for a solar superstorm. The National Academy of Sciences estimated that in the United States alone, such an event could cause $1 to $2 trillion of damage in the first year, with full recovery stretching up to a decade. Compare that with Hurricane Katrina's $125 billion cost, and the magnitude becomes clear. Our ancestors of 1859 saw auroras, lost telegraph lines, and moved on. Today, everything is different. The more advanced our technology becomes, the more fragile we are to the sun's violence. Our power grids are interconnected across vast regions, making cascading failures likely. Satellites run communications, navigation, weather forecasting, banking transactions, and even the clocks that power the internet. Air travel relies on GPS and high-frequency communications vulnerable to flares. Military defense systems could mistake solar interference for enemy activity, creating dangerous confusion. This interdependence means that a single storm could ripple through every part of global society. Agencies like NASA, NOAA, and ESA monitor the sun tirelessly. Governments run doomsday drills to imagine the effects of space weather. But the truth? We are far less prepared for this kind of disaster than we are for hurricanes, earthquakes, or even pandemics. Transformers take years to manufacture and replace. Backup systems can only last so long, and our ability to predict which region will be hit hardest is still very limited. Dr. Baker of the University of Colorado once noted, "If you lose power for an extended period of time, you're in big trouble. Within days, society begins to break down." If you're fascinated by how space weather can shape our lives in such profound ways, don't forget to subscribe to Starsky Science. We bring you these deep dives into cosmic events so that more people can understand both the beauty and the danger of our universe. In the next of this exploration, we will break down what daily life would look like during a long-term solar storm blackout, from how hospitals would struggle, to how food distribution chains would collapse, to how governments might react to keep order when technology fails. We'll also examine whether there are any solutions. Can we shield Earth from solar storms? Or at least prepare enough to survive one? Because while the sun gives us life, it also reminds us of our vulnerability. And the day it attacks Earth will be unlike anything humanity has ever faced. Imagine this. The storm has struck, the sun has unleashed its fury, and Earth has taken a direct hit. At first, it seems like an inconvenience. Maybe the power flickers, or your GPS tells you that you're driving in the middle of the ocean. But within hours, the scale of the disaster reveals itself. This is no ordinary blackout. This is the collapse of modern civilization's nervous system. In the opening hours after a superstorm impact, satellites fail one by one. The International Space Station struggles to keep its systems stable as astronauts inside watch the auroras race across the planet below. Airlines ground their fleets after communication with aircraft becomes unreliable. Banks are unable to clear transactions. Millions of people cannot use their debit cards or access cash. Electric grids begin to shut down across continents. Not just neighborhoods, not just cities, but entire countries flicker into darkness. Imagine New York, London, Paris, and Tokyo all going dark on the same night. Emergency generators kick in at hospitals, but they are only designed to last a few days at most. For ordinary people, confusion spreads first. Why is my phone dead? Why is the internet down? As hours turn into a day, the realization grows. This is no short-term outage. Something bigger is happening. Without power, the water stops running. Electric pumps that deliver clean water to homes and cities fall silent. Within 2 days, taps run dry. Supermarkets, already unable to process payments, now face empty shelves as trucks cannot refuel. Gas stations depend on electricity to pump fuel. Transportation freezes. In hospitals, ventilators and life support machines rely on backup generators. The ticking clock on their fuel reserves becomes a race against time. Doctors, already strained, face impossible choices. The modern miracle of medicine suddenly looks fragile. Communications grind to a halt. Without satellites, there is no GPS, no weather forecasts, no global positioning for shipping lanes. Cargo ships filled with food and resources float aimlessly in the oceans, uncertain of safe passage. Air traffic halts. For the first time in modern history, the skies are silent. One of the most underestimated aspects of a solar disaster is the psychological shock. Human beings are creatures of routine. We expect the lights to turn on when we flip a switch. We expect our phones to connect us instantly to friends, families, and the wider world. When that is stripped away, fear sets in. In cities, the night sky glows with auroras, dazzling and terrifying at the same time. Social order begins to fray. Looting breaks out as desperate people seek food, fuel, and water. Governments attempt to declare states of emergency, but without reliable communication networks, their reach is limited. NASA and the scientific community may know the cause, but to the average person, this event feels apocalyptic. Rumors spread faster than facts. Panic feeds panic. Even if the blackout were short-lived, the impact on the global economy would be devastating. Stock markets, digital transactions, supply chains all rely on precise timing signals delivered by satellites. With those gone, the financial system seizes like a stalled engine. Now imagine if the outage lasts not for days, but for weeks or months. Billions of dollars in perishable goods spoil. Factories close. International trade collapses. In developing nations, where power grids are less resilient, entire economies could be set back decades. This isn't speculative. Reports from the National Academy of Sciences and the Royal Academy of Engineering have already warned that a solar superstorm would dwarf the damages of any natural disaster in human history. How would world leaders react? In 1989, when Quebec went dark for just 9 hours, chaos was already significant. Scale that up to entire continents, and governments would face impossible decisions. Martial law may be declared in some regions to maintain order. Military forces, themselves dependent on satellites and secure communication, would scramble to adapt. Food distribution would likely be the highest priority. Within 3 days, urban populations would begin to run out of supplies. Rural areas might fare slightly better, but fuel shortages would strangle agriculture too. Dr. Daniel Baker once warned that the real threat isn't just technological, it's societal. When people lose trust in their institutions, when survival instincts override cooperation, the world changes overnight. If you're listening to this and realizing how thin the line is between order and chaos, it's a good time to pause and subscribe to Starsky Science. Understanding these cosmic forces is not about fear, it's about awareness. The more people know, the better humanity can prepare. We already have examples of smaller scale disruptions to learn from. In 1967, a solar storm knocked out US military radar systems, leading commanders to suspect Soviet jamming. For hours, the world teetered on the edge of nuclear escalation until scientists confirmed the sun was to blame. In 2003, the Halloween storms knocked out 47 satellites, diverted commercial flights, and caused power outages in Sweden. Even those medium-sized storms caused billions in damage. Imagine multiplying that by 100. And remember, 2012, the storm that just missed Earth by a week. Had it struck, we would not be speculating. We would be living through the recovery right now. This question divides experts. Optimists believe that society could adapt, finding new ways to rebuild grids, repair satellites, and restore order within months. Pessimists argue that the shock would be so severe that the world economy could collapse, leading to political unrest, wars over resources, and decades of regression. The truth may lie somewhere in between. Humanity is resilient, but resilience depends on preparation, and preparation depends on awareness. Right now, awareness remains dangerously low. In the next, we will explore whether humanity can shield itself from the sun's violence. Are there engineering solutions, like hardened power grids or satellite defenses, that could buy us time? Could we one day predict solar storms with the same accuracy we predict hurricanes? Or are we ultimately powerless, waiting for the sun to decide our fate? One thing is certain: the sun does not care about human schedules, economies, or borders. Its storms are inevitable. The only question is whether we meet the next one prepared or unprepared. The sun does not change its behavior to accommodate human technology. It has erupted for billions of years, long before cities, satellites, or power grids existed. If we want to coexist safely with our star, then it is humanity that must adapt. But how? The first line of defense lies in prediction. Just as meteorologists track hurricanes, space scientists are trying to forecast solar storms. Right now, our warning system gives us only hours, sometimes minutes of lead time. Imagine trying to prepare a city for a hurricane with only 30 minutes of notice. It's impossible. Researchers at NASA, ESA, and agencies around the world are developing new models of the sun's magnetic fields. By studying sunspots and their twisted magnetism, they hope to spot eruptions before they happen. The Parker Solar Probe, currently diving closer to the sun than any spacecraft in history, is helping us map the birthplace of solar wind and CMEs. Every byte of data it sends back brings us closer to understanding how these storms begin. But prediction alone is not enough. We need resilience. Our power grids today are vulnerable because they were designed without space weather in mind. Transformers, the heavy, irreplaceable lifelines of electricity, are the Achilles heel. If a geomagnetic storm surges through them, they burn out, and replacing one can take a year or more. Some experts propose creating stockpiles of spare transformers around the world, ready to deploy in an emergency. Others argue for redesigning the grid entirely, using modular systems that can isolate and protect themselves when currents surge. Satellites, too, must be hardened. Engineers are exploring radiation shielding, backup systems, and even the possibility of turning satellites off temporarily when a storm is detected. It's a costly upgrade, but consider the alternative: losing the GPS constellation, the foundation of navigation, timing, and finance. There are even bolder ideas. Some scientists have suggested deploying a giant magnetic shield at the Lagrange point between Earth and the Sun. In theory, such a shield could deflect some of the charged particles from solar storms, creating an artificial buffer zone. It would be like building a space umbrella for our planet. The challenge, of course, is scale. Such a project would require resources and cooperation on a level humanity has never attempted. But is it really more unrealistic than allowing civilization to collapse? Beyond engineering, there is also the need for global cooperation. Solar storms do not respect borders. A flare aimed at North America would ripple across Europe, Asia, and Africa. Satellites in orbit serve all nations, not just one. This means that protecting Earth from space weather may be one of the few challenges that truly require global unity. The World Health Organization coordinates during pandemics. The International Atomic Energy Agency monitors nuclear safety. Perhaps what we need is an International Space Weather Authority, with the power to coordinate response and preparation. At the same time, awareness among ordinary people is essential. Most of humanity does not even know what a coronal mass ejection is, let alone that it could bring down the grid tomorrow. If people are unaware, they cannot prepare. Simple measures, keeping backup batteries, water supplies, and emergency radios could make the difference between panic and resilience. But until the threat is communicated clearly, preparation will remain in the hands of scientists alone. It's worth remembering. The Carrington Event happened before airplanes, before computers, before nuclear power. Humanity was lucky. The next great storm will not strike the same world. It will strike a hyper-connected civilization. That means the stakes are higher, but so is our capacity to respond. Let us imagine a different scenario. The year is 2035. Humanity has invested heavily in space weather defenses. A fleet of satellites watches the sun from multiple angles, feeding data into artificial intelligence models capable of forecasting solar storms days in advance. A massive storm brews on the surface, twisting magnetic loops into knots. The AI predicts a 90% chance of a CME aimed at Earth. Immediately, global protocols activate. Airlines reroute flights away from polar regions. Satellites enter safe mode, protecting their circuits. Power grids prepare to shed load, isolating vulnerable transformers before the surge arrives. Hospitals switch to protected microgrids. The public receives alerts not with panic, but with calm instruction. Conserve energy, limit travel, prepare for temporary communication disruptions. When the storm strikes, auroras once again dance across the skies. But this time, the story is different. Blackouts occur, but they are limited. Satellites reset, but they are not destroyed. Within days, normalcy returns. Humanity weathers the storm not by luck, but by preparation. This scenario is not fantasy. It is the direction science is pushing us. But the window is closing. The sun is entering a new cycle of activity, and major eruptions are becoming more likely. Every year of delay is a gamble against nature. The lesson is clear. Survival in the age of solar storms depends on foresight. Unlike earthquakes or volcanic eruptions, the sun gives us warnings. The challenge is listening to them and acting in time. NASA's Dr. Janet Lumen once said, "The question is not if a major storm will hit Earth, but when, and whether we're ready or not will make the difference between a natural spectacle and a global catastrophe." As our civilization stares at its glowing star, we are reminded of an uncomfortable truth. The same sun that gives us life can take it away not by burning the Earth, but by striking at the fragile systems we have built. The choice lies with us. Will we prepare for that day or leave it to chance? And if you want to continue exploring these questions, the threats, the science, and the possible solutions, make sure you subscribe to Starsky Science. Because the sun is not done with us, and understanding it may be the key to our survival. When the storm has passed and the auroras fade from the sky, humanity faces the true test, not the storm itself, but the struggle to recover from it. The sun may have moved on, but Earth remains scarred. Cities lie in darkness. Entire continents sit powerless. Satellites that once stitched the world together drift silent. For many, the first question is simple: when will the lights come back on? But as hours turn into days, the grim reality sinks in. Recovery is not a matter of flipping a switch. It is a monumental challenge that could take years. The world we live in today is built on delicate interconnections. Electricity powers communication. Communication drives the economy. The economy supports food production, healthcare, transportation, and security. When electricity fails, the entire chain collapses. In the aftermath of a solar storm, the most immediate priority is survival. Hospitals ration their fuel supplies for generators. Without refrigeration, vaccines spoil and blood banks go dry. Farmers, cut off from fuel and digital supply chains, struggle to harvest crops. Cities dependent on constant inflows of food find themselves on the edge of famine within weeks. The irony is that the sun does not need to destroy buildings or roads to cripple humanity. By striking our invisible systems of power and data, it can unravel everything. Imagine walking through a major city 1 month after a solar superstorm. Traffic lights are dead, ATMs are useless. Supermarkets stand half empty, their shelves picked clean during the first week of panic. Bottled water has become more valuable than gold. At night, the skyline is a shadow. The familiar glow of neon signs and skyscraper lights is gone. Instead, the Milky Way arches across the sky as it did for our ancestors. It is breathtaking, but it is also a reminder. Modern civilization has been reset. Rebuilding begins with power. Engineers and governments focus on restoring grids one piece at a time. But here lies the challenge. High-voltage transformers destroyed by geomagnetic surges cannot be replaced quickly. Manufacturing a single unit can take a year, and shipping it across oceans requires coordination in a world where global trade has collapsed. Some regions with smaller, modular grids may recover faster. Others could remain dark for years. The divide between nations with resources and those without deepens. Satellites, once silent, must be replaced. Launching replacements requires rockets, fuel, and functioning industries, all of which depend on electricity and global cooperation. The internet, once a symbol of human unity, may take decades to fully return. History tells us that in times of crisis, societies either collapse or adapt. After a solar superstorm, both outcomes could unfold side by side. Some nations might embrace cooperation, pooling resources to rebuild. Others might turn inward, guarding their remaining supplies and tightening borders. Power vacuums could emerge as fragile governments lose control. In some regions, military regimes might step in. In others, local communities could become self-reliant, forming microeconomies based on barter and direct trade. The world order we know today could be permanently reshaped by a single storm. History tells us that in times of crisis, societies either collapse or adapt. After a solar superstorm, both outcomes could unfold side by side. Some nations might embrace cooperation, pooling resources to rebuild. Others might turn inward, guarding their remaining supplies and tightening borders. Power vacuums could emerge as fragile governments lose control. In some regions, military regimes might step in. In others, local communities could become self-reliant, forming microeconomies based on barter and direct trade. The world order we know today could be permanently reshaped by a single storm. And yet, human beings are remarkably adaptable. Archaeological records show that our species has survived ice ages, supervolcanoes, and pandemics. A solar storm would be catastrophic, but it would not erase us. Families would learn to live without technology. Farmers would return to traditional methods. Knowledge, preserved in books and offline archives, would guide new generations. Some scientists even argue that a solar storm, while devastating, could serve as a wake-up call, forcing humanity to build a more resilient civilization. A world less dependent on fragile systems, more mindful of nature's power. In the decades after such an event, future generations would look back and ask, why didn't they prepare? Why did they ignore the warnings of scientists? Why did they assume the sun would always remain gentle? And perhaps the greatest lesson would be humility. For all our skyscrapers, satellites, and supercomputers, we are still at the mercy of a star 150 million kilometers away, a star that does not even notice our existence. If you're captivated by these possibilities and want to keep exploring the ways the cosmos shapes our fragile world, make sure to subscribe to Starsky Science. We dive deep into the mysteries of space, not just for wonder, but for awareness. Because awareness is the first step toward resilience. 50 years after a solar superstorm, the scars would still be visible. Some nations might fully recover, building hardened power grids and advanced satellites immune to radiation. Others might remain locked in a new dark age, relying on local resources and abandoned from the global stage. It is possible that the world could split into two paths, one technological, rebuilt stronger than before, and another more traditional, where communities live closer to the rhythms of nature. This dual civilization could redefine humanity's future. Space exploration might slow down, but eventually, curiosity would drive us upward again. And this time, with the memory of catastrophe, we would build systems that can survive the sun's wrath. The story of solar storms is not just about disaster. It is about choice. We can choose ignorance, pretending the sun is harmless until the day it strikes. Or we can choose preparation, building a civilization aware of the star that both sustains and threatens it. The next great solar storm will come. That much is inevitable. What happens afterward, collapse or resilience, depends on the decisions we make now. When we talk about disasters on Earth, we usually think of earthquakes, hurricanes, or even asteroid impacts. But few people realize that one of the greatest dangers to our world comes not from deep space, but from our own sun. And while humanity has faced many storms before, the next great solar strike could rewrite history in ways we can barely imagine. Scientists often describe solar superstorms in technical terms: coronal mass ejections, plasma clouds, geomagnetic disturbances. But behind the scientific language lies something far more unsettling: the possibility that a single outburst from the sun could turn our technological civilization into rubble overnight. Imagine a solar storm not just as powerful as the Carrington Event of 1859, but many times stronger. Some solar physicists have warned that the sun is capable of eruptions, so vast they make our previous encounters look like sparks compared to a bonfire. In such a scenario, entire constellations of satellites could be wiped out within minutes. The GPS system that guides planes, ships, and smartphones would vanish. Global internet infrastructure, reliant on undersea cables and orbital relays, would collapse. Military communication networks, banking systems, and emergency services would be cut off. Worse still, the electrical grids across continents would fry under the surge. Massive transformers would explode in showers of sparks. Substations would burn. Blackouts wouldn't just last days or weeks, they could stretch into decades. For most of human history, we lived without satellites. But now, nearly every aspect of our world depends on them. Weather forecasting, agriculture planning, disaster warnings, television broadcasts, global finance, even time synchronization between continents. If a solar storm destroyed satellites in bulk, the consequences would be immediate and overwhelming. Planes flying over oceans would lose navigation. Cargo ships would drift off course. Farmers would lose seasonal data. Meteorologists would be blind to incoming hurricanes and typhoons. In other words, a solar storm could roll humanity back not just technologically, but socially and economically, undoing centuries of progress in a matter of hours. One of the most chilling possibilities raised by scientists is the vulnerability of nuclear power plants. These facilities rely on stable electrical systems for cooling reactors. If the grid fails and backup generators run dry, reactors could overheat, leading to disasters on the scale of Chernobyl or Fukushima, multiplied across dozens of locations worldwide. The irony is haunting. In trying to generate energy for our future, we may have created another weak point that a solar storm could exploit. NASA researchers once conducted a thought experiment. What if a Carrington-class storm hit the Earth today? Their conclusion was sobering. The cost could exceed $2 trillion in the first year alone. But even more concerning was the human cost. Millions, perhaps billions, could be left without food, water, or medical care. And this is without even considering the global chaos such an event would unleash. Stock markets frozen, governments paralyzed, citizens desperate. The modern world thrives on complexity. But complexity can collapse quickly when its foundation electricity is removed. At Starsky Science, we believe awareness is the first step toward resilience. If you're fascinated by the power of the sun and the fragile line on which our world balances, don't forget to subscribe to the channel. It helps us continue uncovering the science that matters, the science that could one day save lives. To understand what the sun can do to us in the future, we need to remember what the sun really is. A gigantic nuclear furnace, burning at its core for over 4.5 billion years. And like all stars, it has a life cycle. Right now, we live in what astronomers call the sun's middle age. It is relatively stable, but stability does not mean safety. The sun is constantly shifting, breathing, and throwing tantrums in the form of solar flares and coronal mass ejections. As the sun grows older, it will eventually expand into a red giant, swallowing Mercury and Venus, and perhaps even the Earth itself. Long before that day comes, solar storms may grow even more unpredictable, unleashing energy far beyond anything we have yet seen. The real question is not whether the sun will erupt, it will. The question is whether humanity will be ready. Some scientists propose building solar shields, vast structures in space that could deflect or absorb the worst solar storms. Others imagine hardened satellites and underground power systems, immune to radiation. Still, others suggest that humanity's best defense is to spread beyond Earth, colonizing the Moon, Mars, and eventually other star systems. Because as long as our entire species is concentrated on one fragile planet, we remain at the mercy of our star. Picture this. The year is 2150. Humanity has built cities on Mars and mining colonies on asteroids. The sun unleashes a storm greater than any in recorded history. On Earth, blackouts sweep continents. Satellites are shredded. But the colonies on Mars, with independent power grids and hardened communications, remain safe. For the first time, humanity is not entirely crippled by the sun. We suffer, yes, but we endure. And in that endurance, we prove that our future does not belong solely to one world. When we gaze at the sun, we often see beauty, the warmth of dawn, the glory of a summer day. Rarely do we remember that this same star can also destroy. But perhaps that is the essence of existence itself. The same forces that give life also threaten it. The same star that allows plants to grow and oceans to warm is also the star that can burn away our achievements in a single breath. This duality is at the heart of human survival. To fear the sun blindly is to miss its beauty, but to ignore its danger is to invite disaster. The wise path lies in balance, awe, respect, and preparation. The day the sun attacks Earth will not be the end of the human story, but it may be the end of the world as we know it. From the ashes of blackout and silence, a new world could emerge, one more cautious, one more resilient, and one that finally learns to live not as the master of nature, but as its student. High above Earth, a small fleet of spacecraft keeps constant watch on the sun. Their instruments are designed with a single purpose: to catch the earliest warnings of solar upheaval. Some of them, like NASA's Solar Dynamics Observatory, stare at the star's surface in extreme ultraviolet light, revealing a boiling landscape of magnetic loops and fiery prominences. Others, like the SOHO mission, use coronagraphs to block out the blinding glare of the sun, exposing the halo of plasma that often erupts into space. This vigilance is not casual curiosity. It is a matter of survival. The solar wind moves fast, but not instantly. A coronal mass ejection launched from the sun might take 15 hours, or it might take 3 days to reach Earth. Those few hours are humanity's only warning window, the difference between chaos and preparation. In Boulder, Colorado, a group of scientists works around the clock at NOAA's Space Weather Prediction Center. They are, in a sense, the meteorologists of the cosmos. But unlike weather on Earth, solar weather does not provide endless data points from thousands of stations. Instead, it gives a handful of signals from distant satellites, requiring interpretation, like clues in a puzzle. Every day, they analyze the shape of sunspots, the twists of magnetic fields, and the sudden bursts of radiation picked up by orbiting detectors. Sometimes their predictions are met with skepticism. After all, solar weather forecasting is still in its infancy. Yet the work is urgent. A false alarm may cause panic, but a missed warning could plunge entire nations into darkness. Most people don't know this, but governments occasionally run black sky exercises. These are simulations of a solar superstorm event. Imagine entire command centers filled with military officers, utility managers, and emergency planners, role-playing what would happen if the grid went down across half the country. How would food be distributed? How would hospitals operate without power? How would law enforcement maintain order in cities suddenly shrouded in darkness? These exercises are sobering. Many scenarios end in failure, and yet they are critical because they reveal where humanity is weakest and where we must improve before the sun tests us for real. Long before telescopes, humans watched the sun with naked eyes and fear. In 774 AD, Japanese and Chinese scribes recorded a red crucifix in the heavens, a sky that glowed for days. Modern researchers believe this may have been a solar storm, one strong enough to leave radioactive isotopes in tree rings across the globe. To the ancients, these events were omens, signs of divine anger. To us, they are scientific evidence. And yet the emotional reaction is not so different. Whether in medieval Kyoto or modern New York, a sky burning with unnatural auroras inspires awe and dread. One of the greatest frustrations for solar physicists is that the sun is inherently chaotic. Its magnetic fields twist and writhe like tangled wires. These fields build pressure, snap, and release energy in ways that defy perfect prediction. Some compare it to earthquakes. We know stress builds along fault lines, but we cannot say the exact moment the ground will crack. The same is true for the sun. We can measure magnetic complexity on its surface and guess that a storm is likely, but to pinpoint when and how big remains beyond us. That uncertainty is humanity's greatest vulnerability. When people think of solar storms, they often imagine North America or Europe going dark. But the truth is that no region is immune. In fact, some countries may be more vulnerable than others. High-latitude nations like Canada, Norway, and Finland lie closer to the polar magnetic funnels where charged particles enter the atmosphere most easily. Their grids, stretched across vast wilderness, are especially exposed. At the same time, nations closer to the equator, often less wealthy and less prepared, could suffer equally devastating impacts if satellites were lost. Communications across Africa, Asia, and South America depend heavily on orbital relays. A solar storm that knocks them out would strand millions without connection to the outside world. It is easy to focus on the technological effects of a solar storm, the fried circuits, the dead satellites, but perhaps the most profound impact would be psychological. How would humanity respond if, one morning, the world simply stopped working? Picture waking up to find your phone useless, your city without power, banks closed, cars without fuel because pumps require electricity. Panic would spread quickly. Social order is fragile even in times of plenty. In times of sudden deprivation, desperation rules. Some psychologists argue that the first week of a solar blackout would decide the fate of entire nations. Communities that remained calm, shared resources, and maintained trust might survive. Those that turned to chaos would collapse before aid ever arrived. Interestingly, some scientists suggest that solar activity may influence more than just electronics. There is evidence, though, controversial, that fluctuations in cosmic rays, modulated by the sun's magnetic field, may subtly affect Earth's climate. Some studies hint at correlations between solar cycles and historical periods of drought or cooling. If true, the sun is not just a distant threat waiting to unleash catastrophe. It is an ever-present influence, shaping the rhythm of life on Earth in ways we barely comprehend. At Starsky Science, our mission is not to spread fear, but to illuminate the delicate balance of forces that govern our existence. Knowledge is the shield humanity must carry. And if you haven't already, remember to subscribe to the channel. By supporting our work, you join a community determined to face these cosmic realities with open eyes. Imagine a night sky ablaze with green and red auroras stretching to the equator. For billions, it would be the most beautiful sight of their lives. And yet, hidden behind the beauty would be tragedy, the silent failure of satellites, the grinding halt of commerce, the flicker of dying grids. The day the sun attacks Earth will not be announced by fire raining from the heavens. It will be quiet at first. Lights will blink, screens will fade. Then, suddenly, the modern world will feel like the ancient one. Still, the point of science is not despair, but understanding. And understanding gives us choices. Choices about how to build our power systems, how to design our satellites, how to prepare our societies for the unpredictable moods of the star we orbit. The sun may be unstoppable, but ignorance is not. When scientists first began to calculate the destructive power of solar superstorms, a daring idea emerged. What if humanity could build a shield? Not around Earth, but in space, at the strategic point where solar winds flow past on their way to us. This location, known as the Lagrange Point 1, LON, sits about 1.5 million kilometers from Earth, directly between our planet and the sun. Here, gravity and orbital mechanics balance in such a way that an object can hover in relative stability. It is the perfect position for observation satellites, and perhaps one day, for a planetary-scale shield. The concept is breathtaking. A giant structure, hundreds of kilometers wide, made of ultra-thin reflective material, deflecting or absorbing a portion of the incoming solar blast. Even a reduction of 1 or 2% of the solar flux could spare Earth's fragile grids from collapse. Skeptics call it impossible. But then again, so was flight. So was landing on the moon. Humanity has a habit of engineering miracles when survival is at stake. Today's space weather forecasters are limited by human interpretation, but tomorrow's might not be. Artificial intelligence, fed by decades of solar imagery, is beginning to detect subtle patterns in magnetic fields that human eyes cannot. Some models can already predict flare intensity hours in advance with remarkable accuracy. The future may bring a day when AI not only warns us of an impending storm, but also automatically activates protective measures across the globe, rerouting power, grounding satellites, securing astronauts aboard space stations. In a sense, AI will become our planetary immune system, detecting the virus of solar fury before it infects our technological body. No matter how strong our shields or how clever our AI, Earth will always sit in the path of solar storms. That reality has led some scientists and visionaries to propose a more radical solution: move beyond Earth entirely. Mars, with its thin atmosphere and lack of magnetic protection, may seem an unlikely refuge, but with underground habitats and shielded cities, it could serve as a backup civilization. The Moon, though barren, offers the advantage of proximity, a stepping stone for orbital industries and research stations. And then there are ideas that border on science fiction, but are slowly shifting towards science fact: floating colonies in the asteroid belt, O'Neill cylinders orbiting far from solar turbulence, or even interstellar ships carrying human knowledge to distant suns. When the sun lashes out, Earth is vulnerable, but humanity, spread among worlds, could endure. To understand the threat, we must place it on a cosmic timeline. The sun is middle-aged, about 4.6 billion years old. It will likely shine for another 5 billion years before exhausting its hydrogen fuel. In the coming hundreds of millions of years, solar output will gradually increase. Earth will warm. Oceans will evaporate. The habitable zone, that delicate band where liquid water can exist, will creep outward past our world toward Mars and beyond. Solar storms are violent, but temporary. The true, ultimate disaster is slower: the inevitable death of the sun itself. One day, long after humanity is gone or transformed, the sun will swell into a red giant, swallowing Mercury, Venus, and possibly Earth. What we experience today as storms are but whispers of that future inferno. Some of the most ambitious thinkers have suggested building vast megastructures around the sun itself, not to block its energy, but to harness and control it. The concept of a Dyson swarm, a network of millions of solar-collecting satellites orbiting in formation, could provide unimaginable power. If designed correctly, it might also serve as a buffer, absorbing and redirecting bursts of plasma before they reach Earth. This is not just engineering. It is civilization-level evolution. To build on such a scale requires cooperation beyond nations, beyond politics, beyond the short-sightedness that often holds us back. It requires humanity acting as a species, not as tribes. The irony is hard to miss. For billions of years, Earth's life has endured superstorms without issue. Plants kept growing. Animals kept moving. The only reason the sun now threatens us is because of what we've built. Our technology is both our greatest strength and our greatest weakness. The more advanced we become, the more dependent we are on fragile networks of electricity and satellites. It is a paradox. Progress makes us powerful, but also more exposed. Some philosophers argue that solar storms remind us of humility. We are not masters of the universe. We are creatures clinging to a thin magnetic bubble, orbiting a star that can erase our achievements with a single outburst. At universities and research institutes, young scientists are being trained to think not only about black holes and galaxies, but about the sun in our backyard. Many of them will spend their careers designing satellites, writing AI models, and testing emergency systems that could save billions. In classrooms, children are beginning to learn the basics of space weather alongside Earth weather. Some may one day stand in control rooms, watching solar data scroll across screens, and make the call that saves humanity from catastrophe. Knowledge must not stop with scientists. Ordinary citizens must understand that solar storms are not science fiction. They are natural events, and awareness is our first shield. If we survive the coming centuries, if we build shields, train AI, colonize other worlds, there still lies a larger truth. To escape the ultimate fate of the sun, humanity must leave. It sounds impossible today, but consider what seemed impossible 1,000 years ago. In the 11th century, No one would have imagined people flying across oceans in metal machines. In the 19th century, no one dreamed of men walking on the moon. The 31st century may belong to starfarers. If our species endures, we may carry Earth's memory to other suns, ensuring that no storm, no star, no ending can erase us. Here on Starsky Science, we explore these ideas not to terrify, but to reveal the astonishing reality of our existence. We live in a universe where creation and destruction are woven together. The same star that gives us life can also threaten it. If you haven't subscribed yet, take a moment now. By joining our growing community, you ensure these stories continue to be told, stories that remind us how fragile and how extraordinary our world really is. Deep in the core of the sun, hydrogen atoms fuse into helium, releasing the energy that warms our skin and lights our days. This process is steady, but not perfect. Magnetic fields churn, twist, and sometimes break free. When they do, they release solar flares that can dwarf all the nuclear weapons on Earth combined. These events remind us that the sun is not a gentle lamp, but a nuclear furnace balanced on the edge of stability. The day the sun attacks Earth may come tomorrow, or it may come centuries from now, but it will come. And when it does, humanity must be ready. In the age of satellites, solar storms seem like a modern threat. Yet, long before electricity or computers, our ancestors may have felt their presence. In 1859, the Carrington Event lit the skies with auroras so bright that people in Cuba thought it was dawn. Telegraph operators were thrown back by sparks leaping from their machines. Some systems continued to send messages even when disconnected from power, as though the Earth itself had become a battery. But dig deeper into history, and stranger stories emerge. Ancient Chinese records describe red dragons in the sky and celestial fires that lingered for nights. Norse sagas speak of skies torn by fiery rivers. Indigenous tribes of North America painted glowing arcs across their cave walls, eerily similar to auroras. Could these be echoes of ancient solar storms? If so, humanity has been warned for millennia, and perhaps we simply forgot to listen. Imagine, it is a calm morning. The sun looks no different, but 92 million miles away, a monstrous eruption has just left its surface. A coronal mass ejection, carrying billions of tons of charged particles, is now racing toward Earth at over 1 million miles per hour. Hour 1. Space agencies detect the outburst. A global alert is issued. Satellites begin switching to safe mode. Airlines scramble to reroute flights. But billions of people on Earth remain unaware. Hour 12. The first wave of solar wind hits. GPS satellites flicker. Communication signals warp. In polar regions, auroras blossom in midday skies, dazzling but ominous. Hour 20. The full storm arrives. Power grids crackle. Transformers overheat. Lights go out first in scattered regions, then across continents. Hour 30. The modern world begins to unravel. Banks cannot process payments. Hospitals lose power. Water pumps shut down. Within a day, society takes a step back into the 18th century, only this time, billions are unprepared. In ordinary times, hospitals are the beating hearts of our cities. But in a solar storm blackout, ventilators fall silent. Operating rooms go dark, and critical medicines spoil in powerless refrigerators. Doctors would face impossible choices. Who receives the last working generator? Who gets treatment? And who must be left without? In a storm's aftermath, survival would not only be a matter of technology, but of ethics and humanity itself. Few realize how fragile the global food system is. Farmers depend on satellite data for weather. Tractors and irrigation systems run on electronics. Global shipping relies on GPS. A solar storm does not just cut power. It strangles the supply chain that feeds billions. Grain might sit in silent silos while cities starve. Fresh produce would rot without refrigeration. Panic could spread faster than hunger itself, as rumors fill the void left by the silence of dead networks. Darkness has always frightened humanity. But what happens when billions suddenly lose their digital lifelines? No phones, no internet, no news, only silence. Psychologists warn that in such scenarios, fear spreads like wildfire. Entire populations might descend into chaos, not because of the storm itself, but because of what people imagine in the absence of information. History shows us that humans under stress often turn to myths, conspiracies, or scapegoats. In a solar disaster, governments may face uprisings not because the sun attacked, but because trust collapsed. It is no coincidence that so many cultures worship the sun. To the Egyptians, Ra's daily journey across the sky was life itself. To the Aztecs, solar sacrifices kept the world alive. The Japanese revered Amaterasu, goddess of the sun, whose withdrawal into a cave plunged the world into darkness. Perhaps these myths were more than symbolism. Perhaps they were cultural memories of times when the sun truly did vanish behind storms of its own making, when auroras painted the heavens and crops failed. Modern science gives us data and graphs. Ancient people gave us stories. Both, in their own way, warn of the same truth. Our fate is bound to the sun. Picture a historian writing a century from now about the storm that brought humanity to its knees. Their words might echo like this: "I was a child when the great storm struck. The lights went out at dinner, and they never returned. My parents told me the sun had grown angry. For weeks, we lived by candlelight, trading food with neighbors, listening for rumors carried by word of mouth. When the skies glowed green at night, we thought the world was ending. It was only later we learned it was the breath of the sun itself falling upon us." These imagined voices are not fantasy. They are potential testimonies of tomorrow. Some scientists believe solar cycles have influenced Earth's climate in subtle but powerful ways. The Maunder Minimum, a 70-year period of low solar activity in the 17th century, coincided with the Little Ice Age, when Europe froze and harvests failed. If the sun can dim the world for decades, could a surge in activity bring the opposite heat, drought, and famine? Our planet is balanced on a knife's edge, and the sun is the hand that tips the scale. Technology can be shielded, grids can be hardened, satellites can be replaced. But what of human resilience? A society that panics in darkness cannot endure. True preparation may lie not only in engineering, but in education, community, and trust. A people who understand the storm will face it with courage. A people kept in ignorance will face it with fear. The greatest shield, in the end, may be wisdom itself. Every generation faces its test. For some, it was war. For others, plague. For us, it may be the sun. The question is not whether the storm will come, it will. The question is whether humanity will learn, adapt, and rise stronger, or whether we will be humbled, forced back into shadows by the very star that gave us light. The sun attacks not out of malice, but out of nature. To endure, we must remember we are not its masters, but its children. The modern world has never seen a threat like a solar superstorm. Unlike conventional disasters, it does not discriminate by nation, economy, or military strength. The sun attacks all simultaneously. Imagine a sudden blackout that stretches across continents. Electrical grids fail. Communication networks collapse. Fuel distribution halts. Governments scramble to maintain order. In this scenario, old alliances may fracture. Trade routes vanish. Nations hoard resources. The geopolitical balance shifts overnight. A country that once thrived on technology may find itself weaker than a smaller, self-reliant nation. History is filled with resource conflicts, but a solar storm creates a new battleground. Electricity itself. Regions with operational power grids become sanctuaries, while those without fall into chaos. Cities may militarize to protect generators. Borders may be closed to prevent migration toward energy-rich regions. Economists warn that currency itself could lose value if electronic banking fails, replaced by barter or physical commodities. Some governments might consider preemptive strikes to secure energy infrastructure. The world could experience conflicts not over oil or water, but over the fragile wires and transformers that remain alive. As darkness descends, humans may seek safety underground. Modern architects and engineers have already envisioned subterranean cities, shielded from radiation and extreme weather. In a future struck by a massive solar storm, these underground habitats could become essential. Some could be converted subway tunnels. Others might be newly constructed bunkers, equipped with independent power sources, hydroponic farms, and water recycling systems. Inside these shelters, humanity could survive weeks, months, or even years, while the surface struggles to recover. For the billions left on the surface, survival becomes immediate. Water. Without pumps, fresh water must be collected manually from rivers or rainfall. Food. Refrigeration is gone. Preserved and canned goods become essential. Farming and foraging skills regain value. Communication. Radios with hand crank generators become lifelines. Medicine. Hospitals collapse. First aid knowledge and herbal remedies regain importance. Communities that cooperate are more likely to survive. Those that fight over resources may not last a week. Global supply chains are instantaneous today. But when electricity fails, trade grinds to a halt. Ports, airports, and logistics systems fail. Food and fuel become scarce. Some economists predict that physical commodities, grains, clean water, metal would replace digital currency in value. Wealth may shift from financiers to those who can provide food, energy, and protection. Entire economies could be rewritten in a matter of days. The darkness brought by a solar storm is not just physical. It affects the human psyche. Humans crave information, structure, and certainty. Without electricity, these vanish. Panic, anxiety, and despair can spread faster than hunger. Psychologists suggest that maintaining community rituals, shared responsibilities, and communication even through basic signals is critical to prevent social collapse. Survivors may turn to old beliefs or invent new ones. Stories of celestial wrath, once myths, could regain influence. Spiritual leaders might emerge as sources of guidance, or authoritarian figures may exploit fear to seize control. Civilizations have always interpreted natural disasters as divine messages. A catastrophic solar storm could catalyze a new era of mythology. Future generations may tell stories of the day the sun struck, of glowing skies and fire in the air, mixing factual memory with symbolic meaning. Temples and rituals could form around survival strategies, underground shelters, water conservation, and fire safety becoming sacred practices. In this way, a single astronomical event might reshape culture, art, and religion for centuries. Let's imagine an average city on Earth during a solar superstorm. Morning. The first surge hits. Streetlights flicker. Traffic stops. Phones die. People leave work to return home, but encounter chaos in the streets. Midday. Hospitals struggle with patient care. Grocery stores empty rapidly. Water shortages emerge. Families prioritize basic survival: food, water, and shelter. Evening. Communities begin forming small defense groups. Generators are shared or fought over. Radio communication becomes essential for news and coordination. Night. The sky glows green and red with auroras at unexpected latitudes. For some, it is beautiful. For others, terrifying. Humans adapt slowly, learning the limitations of their technology and the value of cooperation. While a storm of this magnitude has not struck in the modern age, smaller events provide insight. The 1,989 Quebec blackout, caused by a moderate solar flare, left millions without power for 9 hours. Though minor in comparison, the event exposed weaknesses in grid design and emergency response. Extrapolate this to a storm 10 or 50 times stronger, and the implications are staggering. We see the need for redundant power systems, independent communication networks, and social structures that can function without technology. In a post-storm world, engineers might redesign infrastructure to survive future solar events. Some ideas include shielded transformers resistant to geomagnetic currents, decentralized microgrids to isolate failures, solar-powered shelters that operate independently of the main grid, offline communication networks using low-orbit satellites, or ground relays with radiation shielding. Human ingenuity, combined with lessons from disaster, could create a civilization stronger than before. The sun is both life-giver and destroyer. Every culture, ancient or modern, struggles with this duality. A solar storm is a reminder that, despite our technology and knowledge, humans remain deeply vulnerable to cosmic forces. The question we must ask is not if the sun can harm us, but how we choose to respond. Do we prepare and adapt, or do we ignore the risk until it overwhelms us? At Starsky Science, we explore these possibilities to inspire both awe and caution. Understanding solar storms is not just an academic exercise, it is preparation for survival. If you haven't already, subscribe to Starsky Science to continue uncovering these hidden threats and the extraordinary ways humanity may face them. After a solar superstorm, the world may split into multiple forms of society. High-tech enclaves with hardened grids, AI-managed infrastructure, and orbital communication systems. Surface communities relying on local resources, barter, and self-sufficiency. Underground habitats acting as safe havens, becoming cultural and educational centers. Over decades, knowledge and resources would gradually reconnect society. Lessons learned from catastrophe could guide a more resilient civilization. Solar storms will come. The only question is whether humanity will be ready. Awareness, preparation, and global cooperation are our best defenses. And while the sun is indifferent to our fate, our choices determine whether we survive its wrath or succumb to it. The story of solar storms is ultimately the story of human resilience, our ability to adapt, to innovate, and to endure in the face of forces far beyond our control. When the sun unleashes its fury, cities without preparation could descend into chaos within hours. The modern reliance on electricity is total, from food production to water purification, from traffic control to medicine. To survive, individuals must think in terms of redundancy and adaptability. Emergency energy sources become lifelines, hand-cranked generators, solar panels shielded from radiation, and even chemical energy systems. Water collection shifts to wells, rain capture, and filtration through natural materials. Food strategies include preserved goods, small-scale urban farming, and foraging. Urban survival becomes a matter of planning, cooperation, and improvisation. Neighborhoods that establish local governance and resource-sharing protocols could maintain order and prevent panic, while others without leadership may descend into violence. Beyond individual and city-level survival, humanity could take on projects that span the entire planet. One idea involves geomagnetic stabilizers, artificially generating magnetic fields to protect critical regions from charged particles. Another concept is orbital debris shields, massive structures in low Earth orbit that deflect the high-energy plasma of solar flares. These structures could act as temporary armor for satellites and orbital stations, buying humanity crucial hours during a solar assault. Some engineers even propose fluid-based global grids, where energy can be stored and transmitted through underground superconducting conduits immune to geomagnetic disturbances. These are speculative ideas today, but could be essential for a civilization that refuses to be at the mercy of the sun. Artificial intelligence could serve as the first and last line of defense. Advanced AI could continuously monitor the sun's magnetic field, detect anomalies, and instantly calculate the potential impact on Earth. When a threat is imminent, AI could automatically redirect satellites to safe orientations, adjust power flows in global grids to minimize damage, alert population centers with precise survival instructions, coordinate emergency response teams across continents. In effect, AI could function as a planetary nervous system, sensing danger and triggering protective measures faster than human response times ever could. For regions most vulnerable to solar flare damage, domed cities with electromagnetic shielding have been proposed. These domes could protect air, water, and electrical systems, while also providing controlled climate conditions during and after a solar storm. Inside such cities, humanity could maintain advanced technology without fear of geomagnetic surges. Outside, the world may be struggling to recover from blackouts, failed communications, and disrupted transportation networks. The contrast between protected enclaves and unshielded areas could reshape the political and social landscape, creating a patchwork of technological havens amid a fragile, storm-scarred planet. If solar activity grows increasingly hostile over millennia, Earth may not remain habitable. In such cases, interstellar escape becomes not just science fiction, but a potential survival imperative. Concepts include generation ships, massive vessels carrying self-sufficient populations across light years; seed probes, sending embryos and genetic material to other star systems to establish new life; warp or near light-speed travel, hypothetical technologies that could shorten journeys across interstellar distances. While these ideas seem fantastical today, they highlight a critical principle. When natural forces threaten global survival, human innovation is boundless. The sun may be violent, but imagination is infinite. Repeated solar storms could produce profound cultural transformations. Societies may adopt new calendars based on solar activity, rituals to honor survival, and stories of resilience that blend history with myth. Economically, nations may prioritize energy independence, local food production, and robust infrastructure over short-term growth. Political power could shift toward regions that maintain stability and adaptability, creating a new hierarchy in global governance. Education would emphasize survival skills, understanding of space, weather, and community cooperation, not just technology and commerce. Humanity would learn to live in synchrony with the star that sustains and threatens it. Imagine an ordinary person experiencing the first massive solar event in modern times. Morning. Streetlights and traffic signals fail. Public transport halts. Workplaces shut down. Midday. Communications falter. Families gather, sharing limited resources. Radio broadcasts provide scattered updates, but misinformation spreads rapidly. Evening. Community leaders organize shared water and food distribution. Local generators are prioritized for hospitals and critical infrastructure. Night. Aurora. Filled skies inspire awe and fear. People adapt to darkness, using lanterns, hand-crank radios, and improvisation to survive. Over time, human resilience, creativity, and cooperation determine whether a community thrives or collapses. The scale of the challenge demands cooperation on an unprecedented level. Nations would need to share energy reserves, coordinate satellite maneuvers, and manage food distribution. Megastructures, AI systems, and underground cities could become interconnected in a global network of survival. Even partial success in coordination could save billions of lives. The lesson is clear. Isolation increases vulnerability. Unity, planning, and preparation transform chaos into endurance. The sun is both our greatest benefactor and our most formidable threat. A solar storm demonstrates the fragility of civilization, while also revealing the potential of human ingenuity. Unlike asteroids or earthquakes, solar storms cannot be diverted or contained with brute force. They demand awareness, technology, and adaptability. They challenge not only our engineering skills, but our willingness to plan for the distant, unpredictable future. In facing the sun's wrath, humanity learns its own limits and its potential. At Starsky Science, our goal is to illuminate these realities. The sun is magnificent, powerful, and indifferent. Understanding its behavior is not merely academic, it is essential for survival. If you haven't already, subscribe to the channel to continue exploring the cutting-edge science, speculative solutions, and human stories surrounding solar storms. Knowledge is the first shield against cosmic fury. After repeated solar catastrophes, humanity may reorganize. Underground and shielded cities become cultural and technological hubs. High-tech AI-managed zones ensure continuity of critical systems. Solar calendars, myths, and rituals help communities adapt psychologically. Interstellar exploration becomes not a luxury, but a plan for species survival. In this way, catastrophe catalyzes adaptation. Humanity evolves not just technologically, but socially, culturally, and psychologically in response to a star that gives life and takes it away with equal impartiality. Solar storms are a test of resilience, imagination, and foresight. While the sun's power is inevitable, humanity's response is optional. Through engineering, AI, cooperation, and preparation, the threat can be mitigated. But beyond technology lies a deeper truth. Survival requires understanding, humility, and the willingness to change. Civilization thrives not because it is strong, but because it learns, adapts, and endures even under a star that can wipe away everything in a single eruption. Imagine a clear morning. Birds sing, people commute, satellites orbit quietly. Few notice the subtle distortions in solar radiation streaming through space. Then, from the sun's roiling surface, a massive coronal mass ejection erupts. Billions of tons of plasma are hurled outward at over 1 million miles per hour. Invisible to the eye, it is a silent harbinger of chaos. Satellites detect the eruption immediately. Space weather centers issue alerts. Power companies initiate protective measures. Yet, for the majority of humanity, the threat is still abstract until it arrives. Hour 1. The first geomagnetic fluctuations hit the outer layers of Earth's magnetic field. Satellites begin minor corrective maneuvers. Astronauts aboard space stations move to shielded areas. Hour 6. Communication satellites flicker. GPS systems fail intermittently. Airlines reroute polar flights to avoid high radiation zones. Power companies begin controlled shutdowns to protect transformers. Hour 12. Urban grids falter. Lights dim. The first outages ripple through cities at high latitudes. Automated systems fail, leaving humans to take manual control. Panic begins to rise. Hour 24. The storm peaks. Transformer failures spread rapidly. Entire regions experience rolling blackouts. Freshwater pumps shut down. Hospitals activate emergency power reserves. Roads jam as fuel pumps and traffic lights cease functioning. Hour 48. Humanity is forced into improvisation. Communities coordinate food distribution, local security, and water collection. Underground shelters and shielded zones become essential refuges. Air travel is one of the first modern industries to feel the sun's wrath. Radiation levels at cruising altitudes rise, forcing flights to lower, less efficient altitudes. Avionics fail as geomagnetic currents surge through onboard electronics. Maritime shipping relies heavily on GPS and communications. Vessels drift, navigation compromised, cargo delayed. Overland transportation slows as traffic lights fail, electric vehicles stall, and communication networks are interrupted. Even automated systems, designed to enhance safety, become liabilities in the absence of reliable power. Humanity is forced to revert to pre-electrical methods, manual signaling, maps, and human coordination. Electricity is the backbone of modern sustenance. Farms rely on irrigation pumps, refrigerated storage, and automated harvesting systems. Urban populations depend on global supply chains. During a solar superstorm, refrigeration fails, causing spoilage of perishable goods. Grain silos without electricity may experience minor damage, but distribution becomes nearly impossible. Clean water is scarce, relying on hand pumps, rain collection, or nearby rivers. Communities that plan for local food production, gardens, livestock, and water purification gain a critical survival advantage. Resourcefulness becomes a decisive factor in life and death. Modern hospitals are highly dependent on electricity. Ventilators, imaging equipment, and surgical tools may fail. Pharmaceuticals requiring refrigeration spoil. Medical teams must prioritize care for the critically ill, ration equipment, and improvise with limited resources. Traditional remedies, knowledge of first aid, and herbal medicine regain importance. Communities with medical training and localized resources have the best chance of surviving. With telecommunication networks down, humans revert to older forms of communication. Radios powered by hand cranks, messenger systems, and coordinated signals. Misinformation spreads rapidly. Social cohesion is tested. Leadership, trust, and community cooperation determine survival. The social fabric strains, but human adaptability allows for new systems of coordination to emerge. Repeated solar storms over months or years could alter culture profoundly. New myths and religions may develop around the sun, its wrath, and humanity's survival. Festivals, rituals, and oral histories may center on survival strategies. Underground shelters, communal resource sharing, and radiation protection. Cultural evolution may prioritize cooperation, foresight, and resilience over consumption and individualism. As solar activity subsides, Humanity begins to rebuild. Power grids are repaired with hardened transformers. Satellites are replaced with radiation-shielded designs. Transportation networks slowly restore functionality. Some urban areas remain damaged for years, while underground cities or shielded zones retain operational systems. Populations migrate, trade resumes, and economies gradually stabilize. New architectural and engineering standards emerge. Buildings designed to withstand electromagnetic surges, resilient communication systems, and self-sufficient microgrids. Solar storms teach humanity the importance of resilience and preparation. Nations invest in redundancy, decentralization, and global cooperation. Knowledge becomes a critical asset. Understanding the sun, space, weather, and survival strategies is as valuable as gold or energy. Humanity also learns humility. Despite technology and ambition, civilization remains dependent on the sun's stability. Respect for natural forces becomes ingrained in culture, education, and governance. The sun is indifferent. It gives life, yet it can destroy with equal impartiality. Humanity's response, awareness, preparation, and cooperation determines whether we survive or succumb. A solar superstorm is not just a natural disaster. It is a mirror, reflecting both the fragility and ingenuity of civilization. It challenges humanity to think beyond short-term gains, to plan for survival, and to act collectively in the face of cosmic forces. After surviving solar catastrophes, humanity may evolve socially, technologically, and culturally. Technology, AI, managed planetary defenses, hardened grids, and shielded satellites become standard. Society, underground or shielded communities flourish, with emphasis on cooperation, survival skills, and education. Culture, myths, stories, and rituals honor survival, resilience, and the sun's power. Space, colonization of Mars, the Moon, and beyond becomes a necessity, ensuring the species can endure even if Earth is severely damaged. In this vision, solar storms become not only threats, but catalysts for growth, adaptation, and collective ingenuity. At Starsky Science, we explore these cosmic forces to understand the delicate balance of life, technology, and survival. The sun is a reminder of both power and vulnerability. By understanding space weather, preparing for solar events, and learning from history, humanity can endure not through fear, but through knowledge, cooperation, and foresight. If you haven't yet, subscribe to Starsky Science to continue exploring the universe, uncovering hidden threats, and learning how our species may survive the most extreme cosmic events. Solar storms are inevitable, but so is human resilience. Civilization's survival depends on our willingness to observe, anticipate, and adapt. Technology alone cannot save us. Only a combination of foresight, knowledge, and cooperation can withstand the fury of a star. The day the sun attacks Earth will arrive, sooner or later. When it does, humanity will face its ultimate test, and from that test will emerge either collapse or a civilization stronger, wiser, and more unified than ever before. The sun is eternal, humanity is transient, but through awareness, preparation, and ingenuity, our story may endure long enough to witness countless dawns, each rising under the same blazing star that both nurtures and challenges life itself.